everyone. Today, my teammates and I are going to present a video about the application of differentiation in our daily life. Before we start, we would like to introduce ourselves. My name is Genevieve Anak Heli and I am from class CDCS 1102D. My student ID is 2022 877444 and I am a student from College of Computing, Informatics and Media.
Hello, my name is Karania Anak ABAT. My student ID is 2022677548. I am from class CS 1102D. Coding is my hobby. I enjoy learning more about it, especially when I encounter new programming language.
Hello, I am MOHAMAD and HARZIQ bin Muhammad DAHANDRA. Given my student ID is 2022843568. So basically, I am the leader of this team, and in this project, we have 4 members: Genevieve, Karen, me, and JERICHO. So the first one is the JERICHO will present introduction. Second, Karen will present about the problem statement. Third, Genevieve will explain about problem statement in visual and problem solving, and I will explain about the conclusion and the recommendation.
Hello, my name is JERICHO ROSALES, and today I'm going to introduce about applied maximum and minimum values. The process of finding maximum and minimum values is called optimization. In real-world application, maximum and minimum problems are encountered in a variety of professions, including engineering, physics, computer science, and a lot more. They have to determine the most beneficial solution while also optimizing various components of a system or a process. All in all, understanding maximum and minimal problem in general give essential tools for optimizing function and determine the best possible outcome in a variety of contexts, making it a fundamental topic in mathematics and optimization theory. Next is I'm going to introduce a bit about differentiation. Differentiation can be defined as a derivative of a function with respect to an independent variable. The derivative of a function fx is represented by f prime x or dy dx and can be interpreted in a variety of ways depending on the context. There is 3 basic rules that need to be followed in differentiation. The first one is product rule, the second one is quotient rule, and the last one is chain rule. Differentiation is important in discovering optimal solutions since it can be used to determine the critical point by studying a function's derivative and using them to maximize and minimize the function.
For the problem statement is
So this is the problem statement in visual where the length of the equilateral triangle is in 10 minus x meter while the length of the square is in x meter. Moving on to the working step. First, we are going to find the area of the square where the square is at length x meter. So we are going to divide it into 4 because square has 4 sides. We obtain that the area of square is 1 over x squared. Moving on to the triangle, we found out that the length of the triangle is 10 minus x. So we are going to divide it into 3 because the triangle has 3 sides. To find the area of the triangle, we are going to use the sine rule, which is 1 over 2 AB sine C. We are going to substitute the value of 10 minus x over 3 into that formula and we will obtain the answer 3 over 4 multiplied by 10 minus x over 3 square. And then we are going to find the total area for the square and the triangle. After that, we will obtain the answer, which is 1 over 16 x squared plus 3 over 4 multiplied by 10 minus x over 3 square. Next, we are going to differentiate the total area by using the chain rule, and we are going to obtain the answer, which is 1 over 8 x minus 3 over 18 multiplied by 10 minus x. After that, we are going to set the value into 0. Lastly, we are going to obtain the answer for x, which is approximately 4.35. This value is usually to find the maximum and minimum area when dA over dx is equal to 0. So, the area is not increasing or decreasing at this point, but it's either maximum or minimum value. After that, we are going to use the second derivative to check whether it is in minimum or maximum value. Next step is we are going to do the second differentiation. And we are going to obtain the answer, which is 1 over 8 plus 3 over 18. It is show us the positive sign. That means it is in minimum value. But if the answer is in negative, it means the area is in maximum value. But we only use the second differentiation only to show whether it is in minimum or maximum value. After that, we are going to substitute the value of 4.35 into the total area, and we are going to obtain the final answer, which is 2.72 meters square. From this, we can conclude that the minimum area is 2.72 meters square when x is equal to 4.35 meter.
Hello there, I am Muhammad Daniel HARZIQ bin Muhammad DAHANDRA. As we reach this point, I would like to conclude the points while giving some recommendations of this given topic. When solving these types of questions, have you ever wondered what is important? Well, you need to master the basics of differentiation first. There are some rules to be memorized, such as chain rule. Second, you need to be aware of the use in this question, whether it is volume or area, which you also need to be aware of the question when to apply second derivative of a function. These are needed to be double-checked because most of carelessness will come from here and it will cost you lots of marks. We also need to be cautious of what formula we are going to use according to the shapes stated in the questions. By mastering all of above, you can use this method to solve the problem in daily life. This method can be used to solve much other different shapes and even deal with something like money. With this method, we also can find the minimum or maximum values of an object or shape, thus making it easier for us to find data such as the increment or the decrement of the values. With the points all wrapped up, I hope you understand what I just explained to you. It has proven that the application of mathematics does help with the revolutionary of the world since back then. I, as the representative of the group, would like to say thank you for your attention, and this is where we meet the end.